Hello and welcome to this lesson on transformations of functions and translations. So to begin with, let's talk about what it means to be a function in very simple terms. So in terms of a function, we could have some kind of graph and plot a curve, which maybe would look like this for part of that curve, and we might label this function f of x, right? So let's write that here, f of x. F of x just is the label that we give to describe the equation that is giving the graph of this curve. In terms of transformations, we're interested in how we can change our function such that the graph of this curve will change in some way. So the different types of transformations that we're eventually going to be looking at involve things like, for example, a reflection. So you could reflect like this into the x-axis. Everything has been flipped horizontally. We could reflect in the y-axis. So actually, in this case, we've reflected over the x-axis technically, but it's been a vertical reflection. And we could also do translations, and this is what we're going to be looking at in this lesson. So here is a horizontal translation. We have essentially shifted our function over to the right by some amount. We could have shifted it to the left, and that is called a translation, a horizontal translation. We could also do a vertical translation, so just shifting the whole function vertically, either up or down. Okay, so to understand how we do these transformations, these translations, let's write it out more explicitly in terms of the algebra. Okay, so let's turn off some of these things here, and the easiest one to talk about is actually the vertical transformation. So for our function f of x, get rid of that guy there. Okay, so our function f of x, if we want to do a vertical transformation, a vertical translation, it's quite simple. Well, what's happening? When you do a vertical translation, all of the y values, if this is your y-axis and this is your x-axis, everything is increasing or decreasing by the same amount. So for some function f of x, we're going to just transform that into f of x plus some number, k. So if k is greater than 0, what's going to happen? Well, this is going to translate up, right? This is a vertical translation. Vertical translation upward. Okay, upward. And how many units will it go up? Well, it's going to be k units, right? Okay. Now, conversely, obviously, if k is less than 0, what's going to happen? Now we're going to have a vertical translation downward. And again, we would go down by k units. So what might be a function that we're familiar with? Okay, well, we could do, maybe an easy one would be a linear equation. So, for example, let's draw a line here. I might have this line going like that. And let's say this line is crossing the y-axis, it has a y-intercept of maybe -5. And let's say that its slope is maybe, looks like a slope of maybe, yeah, let's say it's a little less than 1. So we'll say maybe 3/4. So 3/4 x minus 5. Okay, well that would be the equation of our line. You might be familiar with seeing y here, and that's essentially what this f of x means. It's just saying we have some expression, some function in terms of our variable x, our independent variable. Okay, so if we're going to do a vertical translation of k units, well, I might make a new function. Let's call it g of x. And it's going to just be f of x plus some number of units. Let's make our k value 6. All right, so if we were to write that out in terms of our original function, we'd have 3/4 x minus 5 and then plus 6, right? So now we have 3/4 x, let's write that a little clearer, 3/4 x minus 5 plus 6, that's plus 1. All right, so that's our new function. And what's that going to look like? Well, that's just simply our line. Let's duplicate our line here, and we'll just translate it up by the necessary amount, which is, of course, just 6 units. So now we've translated it up, and now the new y-intercept, our new y-intercept, will of course be 1. And that's what our line says. The slope has stayed the same. This was our original line, and now our new line, g of x, has been translated upward. Okay? Of course, we could have chosen a k that was negative, and then this line would have translated down. This doesn't have to be a linear equation. We could have chosen any type of equation, and this will still work. Just simply add or subtract some value from your original function, and it will go up and down. Okay, now let's look at a horizontal translation. Horizontal translations are also simple, but they're a little trickier than a vertical translation. So if we have some function, let's do our f of x again, and we don't know what the equation is of this curve, but let's pretend that we know what it is, and we just call it f of x. If we want to translate our function, f of x, horizontally, to the left or to the right, what we're going to do is we're going to subtract or add a value to the independent variable x. Okay, so again we have this k, but things are a little, maybe counterintuitive than what you might expect. So if we want to do a left translation, so if we have, in this case, what's going to happen is if k is greater than 0, our whole curve is actually going to translate left. It's a left translation. And again, of course, k units. So what does this mean? It means that every x that appears in your equation will now be increased by a value of k. So if you have several x's in your equation, all of them have to be changed. You might put it in brackets, x plus k is your new x. Okay, and then you might guess it, of course, if k is less than 0, if it's negative, then we're going to translate now to the right. So this might seem a little backwards. I find that most students find that you would think that if k were positive, that you would move the curve to the right, and if it were negative, you'd move to the left. But it's actually the opposite. So why is that the case? Well, you can kind of think of it as your x value is starting at a greater value than it did originally. So if k is positive, what it means now is your x value is actually starting out larger than it would have been. So normally, when your function here starts with x equals 0, you're actually going to start k units more than that. So let's say that k is over here. Whatever k is, could be 10 or something like that. Now, basically, you're looking ahead to what the value of the function was, or would be, when x equals k. And that's where you're going to now start your function. So you're actually starting, your value will be over here. So the whole function is actually getting shifted over to the left. All of these values that would be over here, they're getting pushed over. You get to kind of start early. And it's the same reasoning for why if you have a negative k, the function would be shifting in the other direction. Okay, well, let's consider our case of the line. So now we again have our linear equation 3/4 x minus 5, and we're going to translate this some k units. Let's see what happens if I choose k to be 6 again. So we had done a vertical translation with 6 units. Now let's see what happens if we do the horizontal translation. So we're going to define a new function, g of x. This is going to be our transformation. And as we learned, I'm going to do x plus 6. So can you guess what's going to happen? All right, well, you should remember it's going to shift to the left, right? 6 units. Let's see if it works out. So I'm going to substitute in now. For x, I'm going to write x plus 6 instead in brackets, and then minus 5. Okay, so can you think about what we get? Well, we can just distribute the 3/4 here. So we have 3/4 x. Oops. We have 3/4 x, 3/4 times 6, and then minus 5. Okay, so that's 3/4 x, 3/4 x plus 3/4 times 6. Well, that's the same thing as 9/2. And then we could write 5 as 10/2. And so we see our final translation gives us the equation 3/4 x minus 1/2. Okay, if we were to graph that, it might look something like this. So now it's a line whose slope is the same, 3/4 x, but now the y-intercept is negative 1/2. Notice something interesting about this. Can you see that this is also equivalent to a vertical translation? Because a line continues forever in both directions, if you shift it horizontally, it's actually equivalent to a vertical translation. A bit interesting. So can you figure out what the vertical translation would be equivalent to this horizontal translation of k equals 6? Think about it for a moment. All right, if you had said that you would add 4.5 to your original value, you would be right. So f of x plus 6 for this function, f of x, would be the same thing as f of x plus 4.5, 4.5. All right, and that's it for this lesson.